Hello, it's Mrs. Wallace. I just wanted to do this quick video for you because I know you were absent from class. One of the things that we went over is the idea of consumer utility and looking at how it is that we essentially get the data that we use when we're using a demand curve. So we know that a demand curve, for example, is something that connects price and quantity demanded. And we know that oftentimes we're looking at, data points, when the price is this, the quantity demanded will be this. And when we ask the question, where does some of that data come from? One of the ways we answer that question is the law of diminishing marginal utility. So we want to look at the relationship in a sense that we as consumers have to utility. And the basic idea is that utility is the satisfaction that we get from consumption. And generally we measure utility in consecutive units of consumption. So if you were consuming, say, bagels, you might say, what's your utility for the first bagel, the second bagel? How about the third bagel? And every time you have another bagel, you might be calculating your total utility, but you might also be looking at your marginal utility. How much extra utility do you get from an additional bagel? Utility is not meant to be usefulness. That's a different usage of the word. There's also some subjectivity to this. Somebody's utility is a little bit, like I get 10, utils from the first bagel, maybe 20 utils from the second bagel. The numbers 10 and 20 are kind of hypothetical, but they are relative to each other. So those measurements, units rather, may make sense for me. Somebody else might have completely different degrees of satisfaction when it comes to bagels. A couple of other things about utility. Util is the word we use for 1 unit of satisfaction. So, 60 utils gained from the first bagel. Total util is the total amount of satisfaction. So if somebody's consumed 5 bagels and maybe each bagel gave that consumer 10 utils of additional, 10 additional utils for every next bagel. If the person consumed 5 of them, they would have 25 total utils. Marginal utility is the extra satisfaction from an additional unit. Always think of marginal as next or additional. How much additional utility do you get from consuming the next bagel and then the next one and the next one? And the assumption is that largely these are not necessarily constant. In fact, they generally are not constant. Usually we will see marginal utility diminish over a specified amount of time. Marginal utility is the slope of total utility. You can always find marginal utility by looking at the change in total utility over the change in quantity. So for every next one of a unit, what is the change in total utility? If the total utility of 1 unit is 10 and the total utility of the second unit, consuming 2 units of something, gives somebody 30 utils of utility, then the marginal utility was 20, the difference between the total utility over the, change in quantity. As consumption of a good or service increases, marginal utility obtained from each additional unit of the good or services decreases. This is known as the law of diminishing marginal utility. If you're consuming bagels, assume that initially you might be so hungry that the first bagel is maybe 10 utils. Maybe the second bagel that you have is even more beneficial to you, so you gain more utils. Maybe the second bagel is like 15 utils. Maybe the third is an additional, 20 utils or something like that. You could see, really extensive, marginal utility increases. But at a certain point, the marginal utility obtained from each unit is going to decrease. The 80th bagel that you eat is not going to be as tasty to you as the first one. So over the course of time, more and more and more and more bagels will eventually lead you to less marginal utility. This does explain a downward sloping demand curve, because if I kind of imagine that at greater and greater and greater quantities of a good, I'm likely going to need lower and lower and lower prices in order to incentivize me to buy those goods because I have diminished marginal utility. I'm not going to pay as much for the 80th bagel as I would the first bagel. So I don't value it as much. This is a very common way of looking at utility problems. If you look on the left, you can see we have a lot of data. If you look on the right, you can see we have some graphs. So on the left, understand the very first column here is a quantity column. This is the number of tacos consumed per meal. This doesn't have to be in intervals of one, like 1, 2, 3. It could be like 2, 4, 6, 8. You just have to recognize that in that formula we were saying total utilities, marginal utilities, the change in total utility over the change in quantity. The change in quantity is this the quantity is this very, very first column. So this is like how many tacos. And the second column is telling us what's our total utility from the consumption of tacos. So one taco gives somebody a total utility of 10. 2 tacos give somebody a total utility of 18. So we know the marginal utility of the very first taco was a total of 10. Okay, it equals total utility. You eat one taco, that first taco gives you 10 units of marginal utility, and as a result, you have 10 units of total utility. When you go to eat the second taco yields you 8 units of additional utility. So in total, you now have 18. Okay, then the third bagel gives you additional 6 utils. Now you have a total of 24. Okay, so there is a relationship between total utility and marginal utility. On the top in this graph here, we can see total utility. So what's happening to total utility? It's increasing, it's increasing, it's increasing. So you're eating tacos, you're eating tacos, you're eating tacos, you're eating tacos. And then all of a sudden, there's a peak in your utility and it starts to decline. Let's see if we can figure out what happens. Marginal utility, okay? Even when marginal utility is declining, say from 10 to 8 and then 8 to 6 and so on, your total utility can be increasing. If your marginal utility is decreasing, like it is here, 10, 8, 6, 4, this is diminishing marginal utility. As soon as you're eating the the second unit, you have diminished your utility, okay? It is declining from 10 to 8, from 8 to 6, from 6 to 4, and so on. But at the same time, your total utility is increasing because these are still positive numbers. Even though you're getting less and less and less utility from each next taco, this little utility is still being added to total utility. We would describe this as total utility is increasing, but at a decreasing rate, okay? It's increasing, but because marginal utility is going down, you have a increasing, but at a decreasing rate. When marginal utility is 0, in other words, you have the 6th bagel and you don't have any additional marginal utility. You kind of got 2, utils from the last one, and, there's no additional marginal utility with the next bagel. When your marginal utility is 0, okay, so like right here, it's 0, you're going to see your total utility peak, okay, because there's no additional positive number of marginal utility being added to your total utility, okay? This number, in other words, doesn't do anything. At this point, your total utility would be 30. This addition of 0 doesn't change your total utility at all. You don't have a decrease in your total utility until your marginal utility is less than 0. When your marginal utility is less than 0, it starts to drag down. It's a negative number. It's going to drag down your total utility. This is no longer going to be 30. It's going to be negative. It's going to be 28. Okay. So there is a relationship between marginal utility and total utility. You always want to maximize your total utility, but in order to do that, you're going to make decisions on the margin. The theory of consumer behavior has to do with maximizing your utility whenever you consume something. In this model, which is kind of like an algebraic formula, we're going to assume a couple of things. Number one, that everybody's rational, that you are kind of considering certain things when you're making your decision. You're not acting in a way that's quote unquote irrational, meaning things that aren't going to fit into this model. Basically price and the preferences goods that you want. That's the only thing that matters. We do assume that you have preferences and that you know your preferences, that you know which good you want more. You want to buy this pair of shoes or this pair of shoes, and you like these pair of shoes because of the color or the fit or whatever, that you have preferences. We also assume that you have a budget constraint, that there is a certain amount of money that you have to spend. So what kind of consumption can you do within that budget constraint? And also we assume that prices matter. If you go to the store and prices are a lot higher than they were, say, a few weeks ago, and this is like realistic for right now, what kinds of changes do you see in your spending patterns, right? We know people are buying a lot more or less of a whole bunch of different things because of inflation right now. The utility maximizing rule. Okay, so you're going to make an assumption. Say that you are a consumer and you're standing online at Target. And what you want to do is like look at the items in your cart. And let's just imagine for a second that you have apples and bananas in your cart. You have a whole pile of apples and a whole pile of bananas. And you're about to put an additional good in your cart. Okay, you want to know when you put in that last banana, does the margin of utility of that banana over the price of that banana. So let's say the marginal utility is 10. You get 10 additional, kind of happy points from this banana. And maybe the price is $1. Okay, so the marginal utility per dollar is 10, right? You can get 10 utils for every single dollar. If you get 10 utils for every single dollar, that's the marginal utility of bananas over the price of bananas. If you are putting things into your cart and you're putting things that are bananas, but also some other fruit into your cart, you can kind of decide in relation to bananas, how much of this other good will I put into my cart? If you're maximizing your utility, the last two goods that you put in your cart, one banana and say one orange, whatever the other fruit is, each one has to give you the exact same marginal utility per dollar. If I got 10 utils, per dollar for bananas, but only got 5 utils per dollar for, oranges, I'd want to buy more bananas. I get more bang for my buck from buying for bananas. So you want to work with this algebraic formula, and oftentimes you're given a data set to help you understand how to use this particular, and you want these to be equal. That's the only way you're maximizing your utility. If one is greater than the other, you buy more of the one that is greater. And as you buy more, the marginal utility of that product decreases. So if you buy more and more and more bananas, the marginal utility of bananas will eventually decrease to be less than 10. Okay, so it will be a fraction that gets smaller and smaller and smaller. The utility maximizing rule, this is it. Marginal utility of good X over the price of good X should be equal to the marginal utility of good Y over the price of Y. And that means the very last two goods, for apples in this case and oranges for this case, each one of those has to have the exact same marginal utility per dollar. Remember, marginal utility per dollar is not a constant, so it's going to be very different for the first apple and the fifth apple. So if you're buying 5 apples and 4 oranges, we're interested in knowing, is the marginal utility per dollar of the fifth apple the exact same as the marginal utility per dollar of the fourth apple? If they are, then you've maximized your consumption as long as you are spending all of your budget, okay? This is a very typical problem because we're given a scenario here. Apples are going to cost $1, okay? And I'm going to see if I can get the little, pen to work here. Let's see if I can get the little pen, okay? And I'll see if I can make this make sense a little bit. This is going to cost $1. Okay, so let's put a big line between apples and oranges. The apples cost $1 and the oranges cost $2. Okay, so that means every single orange I buy, I have to spend $2. Every single apple I buy, I have to spend $1, and I only have a total of $7, right? The consumer has $7, so I can't really shop all that much.